Hi friends, welcome to Unacademy. Myself Bhavani. As you all know, Unacademy offers plus courses for Karnataka CET students. Students who want to write CET exam in the year 2021 can subscribe the plus courses. Now those who join the plus courses, what are the benefits they are going to get. First of all, students, both class 11 and class 12 topics that will be done in detail. You will be given a lot of tips and tricks so that you can solve the problems quickly. You are also given daily quizzes and DPP, daily practice papers, and also you will be given lot of mock tests with analysis. So students, you will be given a detailed discussion of the topic. You will be given all those essential ideas so that you can arrive at the answer quickly. We have different plans. We have 12 months plan at the rate of 12,375. We have a 6-month plan at the rate of 10,125, and we also have different top educators teaching different batches. So if you want to be part of any one of these batches, kindly see to it that you will be joining these batches by making use of the code BHAVANILIVE. You will get the discount, whatever essential discount Bhavani, by making use of this code BHAVANILIVE. You have a comprehensive batch. You can join this batch. You also have Kannada batch. In case if you are comfortable with Kannada, you can join this batch. The champions batch for the year 2021 has begun from 15th of October. In case if you are interested, you can enroll your name. There are different combinations available: PCM, PCMB, PCB. Once again, you can join this batch and you can make use of the code BHAVANILIVE and get the discount. Okay. So students, do not forget to watch all my YouTube session, and if you love the session, kindly press the like button. Do not forget to press the bell icon also to get further notification. Also watch all my free classes which are in Unacademy special classes, and kindly watch them. Okay, and do not forget to like and share the videos whenever you feel that it is worthy enough to share it with the other friends. So friends, let us begin with today's class. Before that, without forgetting, kindly subscribe the YouTube channel also. Okay, I can see some of you have joined. Okay, so I hope students, are you ready for today's mock test? All are ready? So shall we begin? So there are free practice tests available under Unacademy, so you can enroll your name and you can crack, try to answer as many as practice tests. See to it that you are facing many tests before you go for the real KCET exam. Okay, so students, we will start now. So today we are going to have a mock test, chemistry mock test on coordination compounds. Okay, so we will go with the question. The effective atomic number of central metal atom in CONH3,6Cl3 is. What is the effective atomic number of cobalt? So kindly students, see to it that you are working on the question. The moment you get the answer, you can write it in the comment box. Now, what is the formula for effective atomic number? Let us write the complex CONH3 6Cl3. Now, as you know, the effective atomic number En is equal to atomic number of the metal. What is the atomic number of cobalt? That is 27. Minus oxidation state of the metal. Formula, I hope you are aware of it. Effective atomic number is equal to atomic number of the metal minus oxidation state of the metal and plus 2 into coordination number. So students, here atomic number is 27. Oxidation state, you know how to calculate. Cobalt X, NH3 is 0, Cl carries -1, you have -3 totally. Sum is equal to 0, that means X is equal to +3. So it is 27 minus 3 plus 2 into coordination number. What is coordination number? The number of coordinate bonds. So how many ligands are there? 6. And all of them are monodentate ligand. If the ligand is monodentate, whatever number we write here is the coordination number. If it is a bidentate, then twice the number. If it is a tridentate, then 3 times. So it is 2 into 6 because monodentate. So you will have 27 minus 3, that is 24, plus 12, you will be getting 36 electron. So answer is option C. Students, any clarification you can ask in the write in the comment box. So in case if you have any doubts. So we'll go to question number 2. Which one of the following metal ions is colored? Students, titanium 4+, vanadium 4+, Cu +1 and Zn +2. So among the following ion, which is colored in nature? Yes, quickly find out and give me the answer. So Ishri, I think as you asked for coordination compound, we are so I think you are joining with your friends. So see to it that students, you give your comments in the comment box. Which one of the following metal ion is colored? Now whenever we say colored, student, there should be a presence of unpaired electron. Presence of unpaired electron means it is colored, and also it is an indication that it is paramagnetic in nature. Okay. Now first one is titanium 4+. Titanium 4+. You know the configuration of titanium. What is it? 3D2 4s2. You should be knowing at least 3D series, student. So 3D2 4s2, you have removed all the 4 electron. That means no unpaired electron. It is 3D0 4s0. So there is no unpaired electron. So this cannot be. Okay. We will see vanadium 4+. You know the configuration of vanadium. 3D3 4s2. If I remove 4 electron, I am going to get 3D1. That means there is a presence of 1 unpaired electron. So it should be colored in nature. Cu +1, you know Cu means 3D10 4s1. So if you remove 1 electron, you have 10 electron, but all the electrons are paired, isn't it? You know when I say D5, it is 1, 2, 3, 4, 5 and then all the electrons are paired. So no unpaired electron. Zinc, you know, zinc is 3D10 4s2. When I say zinc 2+, remove 2 electron, once again all the electrons are paired. So you find in option 1 no electron, unpaired electron. Here all the electrons are paired. So only option left is option B, where you get one unpaired electron. So it is colored. Okay. I hope you are getting the answer, student. Okay, go to the next one. Very simple question. Coordination number of nickel in NiC2O43 4- is. Coordination number is asked. Option A is 3, option B is 12, option C is 6 and option D is 4. So students, can you tell me which one do you think will be the right answer? Coordination number of nickel in NiC2O43 3-. So you can give me the answer. First of all, what is coordination number? What is coordination number? Coordination number means the total number of coordinate bonds. Total number of coordinate bonds. That is called coordination number. Otherwise, you can say how many donor atoms are attached to the metal. That will be also, called as coordination number. In this example, the ligand is C2O4, isn't it? C2O4 2-. What is C2O4 2-, students? It is an oxalato ligand. This ligand is an oxalato ligand, and oxalato ligand is a bidentate ligand. If the ligand is bidentate, twice the number is coordination number. There are 3, twice the number, that means coordination number is 6. Option C is the right answer. Very good, students. So option C is the right answer. Or you can think each ligand is attached to the metal by 2 donor atoms. So 3 ligand will attach by 6 donor atoms. Therefore the coordination number is 6. Or else you can also think like this. Each ligand can make 2 coordinate bond. So 3 will form 6 coordinate bond. Therefore coordination number is 6. So however you understand the concept, you can take it. But then students, remember, in the exam, quickly you need to identify the type of ligand and you have to write it immediately. I hope you are understanding. If it is monodentate, same number, bidentate twice, tridentate 3 times, and it goes on. Okay. So we'll go to the next one. D2sp3 hybridization of the atomic orbitals gives square planar structure, triangular structure, tetrahedral structure and octahedral structure. Very simple question, student. Very simple question. D2sp3 hybridization. Where exactly the orbitals are oriented? How many hybrid orbitals you are getting? D2sp3. 2, 3, see 3 and 3. Totally there are 6 hybrid orbital. How they are arranged, students? The 6 hybrid orbitals are always arranged towards the corner of a octahedron. Therefore, you can see the shape will be, this will give you octahedral structure. This is nothing but octahedral structure. So answer is option D. All these are asked questions, so you can think how the question can be asked, what kind of questions are asked in the exam. So go to the next one. A group of atoms can function as a ligand only when. Now when an atom can act like when a group of atom can act like a ligand? Is it when it is a small molecule, or whether the condition is it should have unshared electron pair, or should it be negatively charged ion, or should it be positively charged ion? So students, when you want to call a group of atom as ligand, what do you expect? What is the answer? Whenever you take a ligand, consider a ligand. Ligand donates electron pair. Now for example, if I take the complex CuNH3 4 2+, you have copper at the center and it is the ligands which are donating electrons to the central metal atom. The 4NH3 ligand will donate electron to the central metal atom. So what is the role of ligand? The ligand need to form, or a ligand need to give a pair of electron. So in order to give a pair of electron to a metal, it must contain unshared electron pair, isn't it? It must contain unshared electron pair. Now the ligand can be neutral, it can be negatively charged, it can be positively charged. So it is not that exclusively it should be positively charged, it should be negatively charged. No, the actual condition is it can have no charge, negative charge or positive charge, but then they should have unshared electron pair which can be donated to the metal and a coordinate bond is formed. Therefore, your answer is option B. So good going students, some of you are giving the right answer. Very good. Okay, so we'll go to the next one. The correct IUPAC name for CrF2En2 Cl. So there are 4 options given student. Kindly work on the question and you tell me which one do you think is the right one. Is it A, B, C, D? The IUPAC name for the compound. So quickly, can you tell me? First of all, you need to find out the oxidation state. But here, we need not find out the oxidation state because all the 4 options have given chromium 3. Therefore, that job is already done by the option. It is given as 3. Therefore, we need not to worry at all. So, we have to directly start a numbering. You can see here, student, there are 2 ligands. One is fluorido and the other one is ethylene diamine. You can see En is nothing but ethane 1,2 diamine. Also it is known as ethylene diamine. Cl is not a ligand, it is outside the sphere. And Cl carries -1, the bracket part, or I can say the square bracket part, the complex part carries a positive charge. So students, very clear now, we need to always name the positive part. There are 2 ligands, one is fluorido and the other one is ethane 1,2 diamine or ethylene diamine. Now since these 2 options are starting as, you see here, chloro cannot be, you cannot have option A because chloro is outside the sphere, it's not a ligand. This is a wrong option. Option B also we need not check because once again they have begun with chloro. So this cannot be. So let us see whether it is option C. So difluorido, of course it is difluorido. Bis, why it is bis? Whenever you have a ligand like ethane 1, diamine. See, this ligand has a term di in it, isn't it? Now when you have such ligands too, if you write di at the beginning, then there will be a confusion. So when a ligand has the name di, tri, etc., to indicate 2 you will use the term bis, to indicate 3 you will use the term tris. So here there are 2, so bis, so difluorido bis ethylene diamine, isn't it? Okay, and then you have chromium 3 chloride. Okay, here also there is no much difference. Only thing is fluoro, they have written fluorido, they have written fluoro. In case if no other answers are there, this is also okay. Nowadays negative ligands we add ido. So the answer can be option C, difluorido bis ethylene diamine chromium 3 chloride. Okay, go to the next one. Crystal field splitting energy for high spin D4 octahedral complex is. So students, in this problem, crystal field splitting energy CFSE is asked, and you know it is for an octahedral complex. So for an octahedral complex, you know the formula, minus 0.4 into number of electrons in T2G plus 0.6 into number of electrons in EG. Now look at the question, student. It's a high spin D4. When I say D4 and if I say high spin, it means that the electrons are not paired. So configuration is T2G3 EG1. If it would have been a low spin, then in the T2G orbital, after 3 electrons are filled, one of the electron will pair, student. Correct? Yes, isn't it? So since it is a high spin complex, the electrons will not pair. So you know minus 0.4, number of electrons in T2G is how much? 3 plus 0.6, and number of electron EG is how much? 1. So minus 1.2 and minus 0.6, that will be minus 0.6 delta O. So CFSE is minus 0.6 delta O. So students, very good, you are answering, giving the right answer. Option C is the right answer. Okay, we'll go to the next one. In a particular isomer of CONH3,4Cl20, the ClCOCl angle is 90 degree. The isomer is known as. Okay, in a particular isomer, see, a particular isomer is given, student. The ClCOCl angle is 90 degree. So the isomer is it a linkage isomer, or is it optical isomer, or is it a cis isomer, or is it a position isomer? So question number 8 among the 4 options, which is the right answer? Students, it is given the COCl bond is 90 degree. You can see cobalt is at the center. There are 6 ligands. So you have octahedral geometry. If you are saying ClOCl and 4NH3, when you write this kind of isomer, the bond angle is 90 degree. And what is this isomer known as? What kind of isomer is this one? identical groups are on the same side. It's a cis isomer. If I would have written Cl opposite like this, then it should have been a trans isomer. Therefore, answer is option C, cis isomer. Go to the next question, student. Which is a diamagnetic? Which is a diamagnetic in nature? So there are 4 options given. You have to find out which is a diamagnetic in nature. Okay. Now students, you can see here, you are given 4 options. In that 2 options, see, when I say diamagnetic, the electrons need to be paired. If all the electrons are paired, then you call it as a diamagnetic. The moment you see an unpaired electron, then it is paramagnetic. Keep in mind. Okay. Now, if you look at the option B and option C, you need to try last because these are weak ligand. So, electron pairing does not take place. So, the only possibility is whether it is option A or whether it is option C, because cyanide is a strong ligand. When cyanide approaches the metal ion, the unpaired electron will pair. So let us see whether it is FeCN6 3-. Now if you can see here, oxidation state of iron is +3, right? Fe is +3 because this is -6 -3, F is +3. So you know the configuration of iron, 3d6 4s2. So you are removing 1 here, that means 3d5, and you know it is like this, 1 2 3 4 5, 3d5. But when it is a strong ligand, the unpaired electron will pair. Okay, you will see 1 unpaired electron even after pairing. That means this is paramagnetic. We will see the next one, COF6 3-. Cobalt is in 3+ state. You know cobalt is 3d7 4s2. Remove 2 from here, 1 from here, that is 3d6. So you know now how to write. Okay. So 3d6, 1 2 3 4 5. So you have 6, 1 2 3 4 5 and 6. Okay, I need to try. I'm trying for Ni. I want to try for NiCN4 2-, right? Okay, here the electron will not pair. Unpaired electron you have. So I told you that we are going to try with option A and option C. Ni is in 2+ state. So you have 3d8 4s2. Remove this 2. That means 3d8. So 1 2 3 4 5. So 1 2 3 4 5 6 7 8. In the presence of strong ligand, this unpaired electron also pair. So there are no unpaired electron. That means it is diamagnetic. So yes, students, very good. Option C is the right answer. Yes, you are doing well, student. Very good. Most of you are giving the right answer. So we will go for the next one. The anion of acetyl acetone forms COACAC3 chelate with CO3+. The rings of chelate are, is it a 3-membered ring, is it a 5-membered ring, or is it a 4-membered ring, or is it a 6-membered ring? So students, what will be the right answer? Anion of acetyl acetone. So what do you think the right answer? acetyl acetone. This ligand is like this. This is acetyl, okay, acetyl, you can see acetyl, this is acetyl group, and this is acetone, acetone, so anion of it. Now this is a bidentate ligand. It can donate 2 pair of electron. So one AC-AC links means it will be linked by 2 center. There are 3 ligands, so it will be linked by 6 center. That means you need to get a 6-membered ring. Option D will be the right answer. I hope I am making it clear. Option D is the right answer. The atomic number of cobalt is 27. The effective atomic number is. Now at the beginning of the class, I have already given you the formula. So students, kindly solve quickly and find out the answer. Atomic number of cobalt 27 minus, you have to write the oxidation state. Now what is the oxidation state of cobalt? Yes, X, this is +3, this is X, this is -2, -1, so there are -4, correct, and this is -2. So oxidation state will be 3 plus 2 into coordination number. You can see there are 4 ligand and there are 2 ligand. All of them are monodentate, that means 6. So you will get the answer as 36 electron. Therefore, answer is option D, student. Answer is option D. Is it clear now? Have you understood? Okay. So I have crossed my time now. So I'm going to stop my class. But then tomorrow, that is day after tomorrow, on 20th, you will have another mock test exactly on, at 2 o'clock. But the same chapter will be continued so that we can have a quick revision on this coordination compound chapter. So students, in case if you like the class, kindly press the like button, and if you have liked it too much, then kindly share the videos among your friends and see to it that you are pressing the bell icon also, okay? So do not forget to subscribe the YouTube channel. So thank you, students. So let us meet on 20th exactly at 2 o'clock with the continuation of mock tests on coordination compound. So bye students, take care.